proofs in this. We're going to be proving that angles are congruent, so less of the segment stuff. Before we prove them, we're going to review some angle pairs. Vertical angles are formed by intersecting lines. This is a review. We learned these last chapter. Vertical angles formed by intersecting lines. I think in chapter 1 we said they were formed by opposite rays, but opposite rays create lines, so let's just say they are formed by intersecting lines. They come in pairs. So angle 1 would be vertical to which angle? 2, good. I think it says name 2 pairs of vertical angles. Angle 1 and angle 2, that would be one pair. Angle 3 and angle 4 are a pair of vertical angles. There has to be lines, intersecting lines, to have vertical angles. Adjacent angles. What does it mean if 2 angles are adjacent? They're next to each other. They share a ray. Good. And they don't what? Good. They don't overlap. Adjacent angles are next to each other. They share a ray, but they don't overlap. Angle 1 would be adjacent to angle 2. Bless you. They're next to each other. They share this ray here. They're not overlapping. Angle 3 and angle 4 are adjacent angles. They share the ray here. Next to each other. Don't overlap. If they're not next to each other, we say they're non-adjacent angles. But they also come in pairs. Complementary. What do we know about complementary, Jimmy? How many of them? 2. Good. 2 angles that add up to 90 degrees. Complementary angles are a pair of angles that add up to 90. Complementary come in pairs. Now, I'm not saying you can't have 3 angles that add up to 90 degrees, but I wouldn't classify those 3 angles as complementary then. Complementary come in pairs. How do we know in our picture that angle 1 and angle 2 are complementary? How do we know they add up to 90? Yeah, the right angle symbol, the little box here. Right angle symbol. Are 1 and 2 congruent? We don't know. It's not marked. Are they adjacent? Yeah, they're next to each other. Okay. How about supplementary angles? Yep, how many of them? 2. Supplementary. 2 angles that add up to 180. A pair of angles that add up to 180. How do we know by looking at that picture that 3 and 4 have to be supplementary? Because they make a straight line. And we know that straight lines are 180 degrees. Good. 3 and 4, adjacent or non-adjacent? What, Mason? Good, they're adjacent. They're next to each other. They're adjacent angles. Good. All right. So using complementary, supplementary, adjacent, vertical angles, we're going to be proving angle theorems today and using them. Remember, a proof is just a logical argument that tells you why something is true. Okay, you have all your steps, your statements on the left side, and then your reasons for each statement on the right side. No matter what type of proof it is, your first step is always the what? The given. Good. Your last step, it should always be what you're trying to prove. You might be able to get there in 3 steps. It might take 7 steps. It could take 10. I don't know. There's different ways to prove something, so there's different results and steps. But whatever your last step is, it should be what is behind the word prove. Okay? We know what they start to look like. Okay. We should be here. Are you here? Given line A and B are intersecting lines, and we want to prove that angle 1 is equal to angle 2. All right? So copy down your given. Number your steps for me, please. I'm going to shorten this up and just say line A and line B intersect. You don't have to say are intersecting lines. We're trying to prove that 1 is equal to 2. I need to get 1 and 2 into my column proof then. Because right now, all I know is that A and B are intersecting lines. But I don't have anything about angle 1 and angle 2. So look at your picture. What can you tell me about the measure of angle 1? Anything, Jonas?
Yeah, that's for the measure of 4.
Do you guys agree with him? That the measure of 1 plus the measure of 4 would equal 180 degrees? Okay. We need a reason for that. Excellent. Angle addition postulate. 2 angles add up to make a third one. 180 is an angle. It's called a straight angle. I don't care that you abbreviate, but just make sure your abbreviation is more than like A there. Okay, abbreviate angle addition postulate. Between substituting and subtracting, go out to 4 letters, because if you only go to 3 letters, they're both sub. Okay, so if you abbreviate, just make sure it's clear that I understand what you're saying. All right, so we have angle 1 in our proof, but now we need to get something about angle 2 in the proof. So I'm trying to prove something about 1 and 2, so I can't just go with 1. Look at angle 2. Do you know anything about angle 2? Jonas, is that your hand up again? What did you want to say? You could say 2 and 4 equal 180. You guys agree with him again? What would be our reason for that? Good, so I can just put it right in that same step. I can just write comma and write the measure of angle 2 plus the measure of angle 4 equals 180. If you wanted to, you could make that step 3 and then write angle addition again, but. Okay, so we're trying to prove 1 is equal to 2. And now I have 1 and 2 in the proof. Only they're in 2 separate equations. I got to make it one equation. 1 equal sign. Jimmy?
Measure of angle 1 plus measure of angle 4 equals the second.
Why?
Because 180 is the same thing.
Good. 1 plus 4 equals 180. 2 plus 4 equals 180. If they're both equal to 180, can't I set them equal to each other? Yeah. You could say that's substitution. Or if I write it out this way, if the measure of angle 1 plus the measure of angle 4 equals 180, and 180 equals the measure of angle 2 plus the measure of angle 4, then 1 plus 4 equals 2 plus 4. Sorry, that was sloppy. What property is this? Good. That's okay. If the measure of 1 plus 4 equals 180, and 180 equals 2 plus 4, we can eliminate that middleman and then just say that 1 plus 4 equals 2 plus 4. Okay? Anytime you want to use the transitive property, that's also substitution. So for step 3, set those expressions equal. The measure of 1 plus the measure of 4 equals the measure of 2 plus the measure of 4. I'm going to write down transitive property, but if you want to put substitution, because it makes more sense with substitution, then put that there. Whenever it can be transitive, then it can also be substitution. Okay, we're getting closer, because we turned it into one equation. We need 1 to equal 2, and I've got 1 equals 2, but there's a 4 in the way. Alex? Yeah, if I subtract the measure of angle 4 from the left side over to the right side, they both end up canceling, and what are we left with? Good, the measure of angle 1 equals the measure of angle 2 by subtraction. Did we get to what we were trying to prove? Okay, let's go back and look at this again. So I've got intersecting lines, A and B, that create 4 angles, 1, 2, 3, and 4. And we just proved that the measure of 1 is equal to the measure of 2. If 2 angles are equal in measure, we say they're what to each other? Congruent, okay? Look at your picture, because mine's kind of not really seen. What kind of angles are 1 and 2? How would you classify them? obtuse and vertical. But we just proved they're what? Congruent. You just proved the first theorem of geometry. Vertical angles are congruent. Some of you already knew this from past years. Vertical angles are always congruent. So what could you tell me about angle 3 and angle 4 in this picture? They're also congruent. Okay? And if you look right below your proof, it should say Theorem 2-1, vertical angles theorem. Vertical angles are congruent.
Couldn't we then just skip all the steps and write down the definition of a vertical angle?
But it's not the definition that tells us they're congruent. It's the theorem.
So could you write a theorem?
Yes, but no. Let me explain. A postulate is a rule that we follow in geometry just because, right? 2 points make a line. A theorem is a rule in geometry that you follow, but the difference is that theorems have to be proven. We had to prove that vertical angles were congruent. You no longer have to prove it. You can now just use that rule from here on out because we proved it in class. Okay? When we prove theorems, you can't use the theorem to prove it. So I have to prove it a different way. And it'll make more sense once we get into chapter 3. Small. Unless it says prove the theorem. But if it doesn't say prove the theorem and it says explain, you would just write vertical angles congruent. And you can write it just like this. You can abbreviate it. Vertical angles are congruent. Okay, it is a tiny little theorem, but a very important theorem. All right, let's flip it over. So your first theorem, vertical angles theorem. We proved it in class. We have 2 more theorems, or I guess 4 more theorems today. We're not going to prove these ones. You don't have to prove them. You can just use them. This first one's called the congruent supplements theorem, which says, if 2 angles are supplements of the same angle, then the 2 angles are congruent. What does it mean to be a supplement of an angle? Yeah, make it 180. They add up to 180. So if I have 2 angles, let's say angle 3 and angle 4, and they're supplementary to the same angle, angle 1, because 1 plus 4 would equal 180, and 3 plus 1 would equal 180. So if 2 angles are supplementary to the same angle, then these 2 angles are congruent. Yeah, I mean, we can see it here because they're also vertical angles. But let's say that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. The measure of angle 1 equals 75. Okay? If 1 and 2 are supplementary and 1 is 75 degrees, what's 2 have to be? 180 minus 75, which is 105. Okay, so 1 and 2 are supplementary, means they add up to 180. 1 is 75, so 2 is 105. Well, 2 is going to still stay 105. It's the same angle. So what does 3 have to be? 75. 2 angles, 1 and 3, supplementary to the same angle, 2, are congruent. 1 was the same as 3. 2 angles supplementary to the same angle are congruent. Okay? That's your congruent supplements theorem. You have a congruent complements theorem. You have 2 angles that are complements of the same angle, then those 2 angles are congruent. What does it mean for angles to be complementary? Add up to 90. Good. Oh, thanks. Appreciate it. In our picture here, we have this right angle. Which 2 angles make up that one? 1 and 2. So we know 1 and 2 are complementary. And then I have another right angle symbol. Which 2 make up that guy? So if I have 2 angles, 1 and 3, complementary to the same angle, 2, then what do we know about 1 and 3? They have to be congruent. Let's pretend that angle 2 is 40 degrees. If 2 is 40 degrees, Tijan, what's 1 have to be? Why? Good. What does 3 have to be, Isaac Birch? Why? Because 2 and 3 make a 90 degrees. So if you have two angles complementary to the same one, they're congruent to each other. Okay? These theorems should act like shortcuts. They should be able to get you somewhere faster. Last two theorems in this section. Theorem 2.4, all right angles are congruent. Duh, right? Yeah. What's it mean to be a right angle? 90 degrees. What's it mean to be congruent? The same. So if I have 18 90-degree angles, all 18 of them are congruent. And then your last one, if two angles are congruent and supplementary, then each is a right angle. Congruent means they have to be what? The same. And supplementary means they have to, okay, so I have an angle x and an angle x because they're congruent. And x plus x has to equal 180, then x must be 90. So if you have two congruent supplementary angles, then they have to be right angles. All right. And then, like I said at the beginning, a theorem is a conjecture or a rule that must be proven. So some guy, mostly Euclid, proved all these theorems for us already. Morning, Mr. Pearson. Okay, so let's use them. Example 1. Using the vertical angles are congruent theorem, we have like 3 or 4 parts here. Part A, find the value of x, which means we have to set up an equation. So look at the two angles with an x in them. Adam, how would you classify those two angles on number 1 with an x in them? Like, would you say they're supplementary, complementary, vertical, adjacent? Vertical, good. Kayla, what do we know about vertical angles today? They're congruent. Mark them congruent in your picture. Use those curves. Kate, if they're supposed to be congruent, what equation can I set up to find x then? Kate. Yeah, set them equal to each other. 4x minus 101 equals 2x plus 3. Now use your awesome algebra skills. Combine like terms. You want to move 4x to the right or 2x to the left? How am I going to do that? Your subtraction property. Subtract the same thing from both sides. 2x minus 101 equals 3. How do I bring my 101 over? Add it using your addition property. So then we get 2x equals 104. And lastly, what do I need to do? And x is equal to 52. Part B says find the measure of the labeled pair of vertical angles. Those are the ones with the x values in them when it says labeled. Isaac Birchill, how would I find the measure of the labeled vertical angles? Yeah, substitute it back in. Yeah. Okay, let's do it into the 2 guy. 2 times 52 plus 3. What's 2 times 52? What's 104 plus 3? 107. Which would mean 4x minus 101 is also equal to 107 because they're congruent, right? Part C says find the measure of the other pair of vertical angles. The guys that aren't marked. Jimmy?
180 minus 107.
Why 180? Good. They form a linear pair of straight line, 180 degrees. So take 180 minus 107, 73. Part D, check to see that the adjacent angles are supplementary. Are they? Isn't that how we figured out what the other vertical angles were? Yeah, we had to use that they were supplementary. All right, vertical angles theorem. Vertical angles are congruent. Example 2, a proof. What's your first step? Okay, copy it down. All right, so you're given angle 1 and angle 2 are supplementary, comma, angle 3 and angle 2 supplementary. given. Write it just as it says. I mean, I put the and symbol in there, an abbreviated supplementary, but 1 and 2 are supplementary, 2 and 3 are supplementary. We have to prove that the measure of angle 1 equals the measure of angle 3. Jimmy? How so? But why? I mean, I need a reason. Bless you. How do you know they equal 180? Oh, good. So we have to be really nitpicky with proofs, and we can't skip steps. Before I can set them equal to each other, I have to have that equation that they equal 180. Okay? So on step 2, we're going to write the measure of angle 1 plus the measure of angle 2 equals 180, comma. The measure of angle 3 plus the measure of angle 2 equals 180. And how did we know that they had to add up to 180? Yes, bless you. Because they're supplementary. So for our reason, definition of supplementary angles. They tell me in the given that they're supplementary. To be supplementary means two angles that add up to 180. Now that we have the two equations set equal to 180, I can set them equal to each other. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 2. What would be our reason there? Yeah, you can use the transitive property, or what else? Or substitution. Either works. It's like that first one we did here with the transitive property. Okay, we're close because we're trying to prove 1 is equal to 3, but I got those darn 2's in the way. Grace, any idea how I can get 1 equal to 3? Yeah, subtract your 2 over. I don't want 2 on the left side. So I'm going to subtract them over, and then they end up canceling it out. Measure of angle 1 equals the measure of angle 3 by the subtraction property. Do these ones seem better than those segment addition postulates? You like those ones? Oh, okay. We have more. Oh. And look, it's a segment. Okay. Given Wx is equal to yz, so that's the ends, we're trying to prove that Wy is equal to xz. What's your first step? All right. When they say Wx equals yz, what does that mean? They're the same length. Excellent. When there's no line above it, they're talking about the length of the segment. Well, if two segments have equal lengths, we can also say they're what to each other? Good. Did you mark it on your picture that they're congruent? Okay, do that now. Wx is congruent to yz. Okay, we're trying to prove that Wy is the same as xz then. Okay. If I'm trying to prove something about Wy, I should probably get that in my proof. So look at Wy in your picture. Do we know anything about segment Wy? Small? Wx plus xy equals Wy. Is that what you said? You guys agree with him? The length of Wx plus the length of xy would be Wy? Ava, what would be our reason for that guy? Good, the segment addition postulate. So we have Wy in here. I should probably get xz into the proof also. Any ideas how we can get xz in there? Jimmy? xy plus yz equals xz. Same reason? Yeah, so you can put it in the same step. Make sure the same number of steps correlates with the reasons. On some of those worksheets, I would get people with 5 steps, but then 6 reasons. Make sure you have the same number. For every step, there should be a reason, and vice versa. All right. We have to somehow make these two 1. Because I want to say wy equals xz. But right now they're in two separate equations. I have to turn them into one equation somehow. Dylan? Wx plus xy equals xy plus yz, is that what you said? What would be your reason?
Because wx and yz are congruent, and then xy is the same as xy.
Yeah, I think so. It takes a second with all those segments. If I'm not thinking what you're thinking, stop me. Wx is the same as yz, so like we could throw them there, right?
Well, because wx and yz are the same, so they equal out on the side, and then yz is on each side because it's the same. Or, yeah, xy.
Like if I substitute yz into that first equation, then I'd get yz plus xy equals wy, right?
Sure.
And then since yz plus xy equals wy, and xy plus yz equals xz, if these two things are equal to the same expression, what can I do with these two things? Make them equal to each other. Do you guys agree with us? We've got to come up with reasons. Bless you. Guys. Substitution for 3. Yeah, that blue one that I have up here. We took yz and substituted it in for wx. How about 4? Yeah, you could do substitution, or we could also do what? Transitive. Xz equals yx plus yz, and yx plus yz equals wy. So I could eliminate that middleman and give us xy equals w, or xz equals wy. You could put substitution, or you can put transitive, whichever one makes more sense to you. Okay? Anytime it can be transitive, it can also be substitution. But just because it can be substitution doesn't mean it's going to be transitive, right? Sure. All right. I really do want to get through these so we don't have to do any on Monday. Number 4, use the diagram and that the measure of angle ABX equals 3x plus 6 and RBC equals 5x minus 20 to find x in the given angle measures. Try this one on your own. Justify, then you'd have to write out the reasons, but you don't have to on this one. As I walk around, 3x plus 6 is labeled on the left side, and 5x minus 20 is the angle to the right. Gabe, what kind of angles are these that we have labeled then? Like supplementary, complementary, vertical, adjacent, any of those? Yeah, they're going to be congruent, but why? What type of angles are they? Are they supplementary, complementary, or vertical? They're formed by intersecting lines. No, because you said they're equal to each other. Complementary means that they would add up to 90, right? Okay, look back at the start of the notes for today, the very beginning of it. What kind of angles are formed by intersecting lines? There you go, vertical angles. These are vertical angles, so they're going to be congruent to each other. So set those expressions equal. Subtract 3x, add 20. 26 equals 2x, divide by 2, and what do we get for x? 13. Good. How do I find the measure of angle ABX then? Substitute it in. 3 times 13, 39, plus 6. So the measure of angle ABX equals 45 degrees. And find the measure of angle XBC. XBC, that's the bottom blank one. How are we going to find that one? Yeah, subtract it from 180. I know that the one on the left is 45. 45 and the blank one form a straight line. That's 180, take away 45. 135? Thanks. Okay. B. Without using the vertical angles theorem, which says vertical angles are congruent, what other theorem can you use to prove that angle ABR, the top one, is congruent to angle XBC, the bottom one? Whoa, Jimmy. Good. ABR, supplementary to RBC, yes or no? Yeah. XBC, bottom one, supplementary to RBC, right? Okay, so at the very top of the previous page, it said, if two angles, the top and bottom one, are supplementary to the same angle, then these two angles must be congruent. So we can use the congruent supplements theorem. Congruent supplements theorem. Two angles supplementary to the same angle are congruent. All right, last two. Number 5, find each angle measure given an angle with a measure 8 less than the measure of its complement. We have to find the two angle measures given that one of the angles is 8 less than its complement. I'm going to show you how I like to set them up. You might set them up differently. The first thing I'm going to go based off of is that they're complements. What's it mean if two angles are complements? They add up to 90, right? Okay, I'm going to create an equation from that. Because they're complements, I know that angle X plus angle Y has to add up to 90 degrees. One angle measures 8 less than its complement. Let's call this one angle an angle. Let's call it X. Measures is, what math symbol goes with the word is? Equals 8 less than its complement. Good, y minus 8. 8 less than would be minus 8, and its complement was y, because x and y were complementary. The complement of x is y. So this part, an angle measure 8 less than a complement, is x equals y minus 8. I have two equations there with two unknowns. I have an x and a y. Hopefully you got to a little bit of this last year. We'll get more of it this year. But when you have two equations, two unknowns, you can solve it two different ways. One way is called elimination, where you line the x's up and the y's up and the numbers up, and then you eliminate down. The other one is substitution. When you solve substitution-wise, you have to get one variable completely by itself. Looking at my two equations, elimination, everything has to line up. The plus, minuses, and the equal signs. Substitution, you have to get a letter by itself. Which one do you think would work better here? Substitution, because I have x by itself. I don't have everything lined up. I mean, my x and y's and numbers, but I have to get those equal signs lined up. So I'm going to substitute. X equals y minus 8. I can substitute y minus 8 into x for the other equation. You have to substitute to the other equation. When you substitute, you get a new one. Y minus 8 plus y equals 90. Now we have one equation with only one variable, so we're able to solve it. Combine like terms, y and y. How do I bring my 8 over? How do I get rid of the 2? 98 divided by 2. So we're saying one angle is 49 degrees. We have to figure out what the other angle is. Well, if y is 49, I'm trying to find x. What's 49 minus 8? So x equals 41. Double check. What's the sum of 41 and 49? 90. Is that what we wanted them to do? Okay. There are your two angle measures. This is the way I like to set them up. Maybe you're someone that can guess and check in your head, but somehow show me that on your paper. How you're thinking it, how you're doing it. Okay. Last one. Find each angle measure given an angle with a measure 3 times the measure of its supplement. Okay, 3 times the measure of its supplement. If they're supplements, what do we know about the two angles? They add up to 180. So create an equation from that. X plus y equals 180, where x and y are the two angles. One of the angles is 3 times the other one. What kind of equation can I write from that if one of them is 3 times the other one? Jimmy? X equals 3y. X is 3 times the other one, so x equals 3 times y. Two equations, because I have two equal signs. Two unknowns, because I have two variables. Means I have two ways to solve it. You can eliminate or you can substitute. What do you think will work better here? Substitute, because I have x by itself. X equals 3y. Substitute 3y in for x in the first equation, and you get 3y plus y equals 180. Combine like terms, how many y's do we get? Divide by 4. $45. 18, I know. Okay, so if y equals 45, how are we going to figure out what the other angle is x? Yeah, you could take 180 minus 45 because we know they're supplementary. Or we could also take 45 times 3, and we would get the same answer. So here are your two angles. Nito is right. Homework today.